All right, guys, so we're going to learn our lesson today on quadratic modeling. And I'm going to answer questions that you probably had on your homework. Hopefully, you guys read the directions and you understood. So, a couple of times throughout the lesson, I'm going to tell you that you should pause and you should work on the problem. You really should pause the video and work on the problem so that then you can check your answer to see whether or not you got the right answer. So, first of all, my warm up question. So, here I have a table of data, and I want you to know, or I want you to decide, is the following data linear? And I want you to pause the video and take a second to think about that. So, hopefully, you have decided that the data is in fact linear. And hopefully, in order to do that, you looked at these numbers and you said, okay, well, maybe you analyze the slope. That's one possibility. And so you looked that each time the x values, they seem to be going up by 5, right? From 2 to 7 is up 5, from 7 to 12 is up 5, and from 12 to 17 is up 5. And so as the x values are going up by 5, what are the y values doing? And it looks like the y values are going down by 3 each time. So we would say that the data in the table is in fact linear because there is what we seem to have as a constant slope. The change in y divided by the change in x is constant. It's always -3 over 5. And so we have a constant slope. So now I direct you to your packet. And, oh, we'll look at the packet in 1 second. Sorry. First, I'm going to point you in the direction of the homework that you guys had. So you were asked last night to come up with graphs or equations for the graph that you see. And we were giving you one of the ways. And that's basically what we're going to be doing all class day. We're going to come up with equations for graphs. So the equation that you were working off of was the vertex form of the quadratic. And the vertex form is quite easy because you basically just need the vertex, h comma k, and you just need one other point so that you can find a, which is whether or not, how wide or how narrow the parabola is, and tells you whether or not it opens up or down, as we've reviewed before. So here are the answers. Number 1, it's -5 x plus 1 squared plus 4. Now, hopefully you did not just all leave an a in front of these parentheses, as it kind of I would have in the graph, and it definitely is not just x plus 1 squared plus 4. You locate the vertex right here at -1, +4, and that's where these values come from. This is h and this is k. And then you find another good point. And by a good point, we mean a lattice point, meaning a point that really goes through on the on the grid, right? Not one that we're going to kind of guesstimate. So here I use the point 0, -1. And what you do, if you weren't able to figure this out, is you take that equation, y equals a times x minus h, so that x plus 1 squared plus k, which in this case is 4, because that's the y coordinate. And then you take your good point, so 0, -1 is my good point, and we plug that in just like you did in Algebra 1 when you wrote the equation of the line. You plug that in for x and y. And in Algebra 1 we were solving for b, and now we're obviously going to be solving for a. So we have -1 equals a times 0 plus 1 squared and plus 4. And if we solve that, this becomes a squared, or sorry, 1a, and then I'd minus the 4 to the other side, so that's why I have -5 equals a times 1, which is obviously just a, and that's why this value of a over here you'll see is -5. Now, if you did not understand that from last night's homework, make sure you go back and you actually pick one of those good points and find the value of a correctly. So if you need to go ahead and pause the video now and redo numbers 2, 3, and 4, that is my suggestion to you. Now, if you did understand that, you can turn your attention now to the packet, the note packet. So at the top of the note packet, we're talking about real world situations here. And it's really common for us to start off with data points that we need to come up with an equation for, rather than somehow getting an equation and using that equation to predict things. And scientists use this all the time, this kind of modeling technique where we get data points and we try and figure out what kind of an equation would work for those data points. So quadratic data is a little bit different than linear data, but we can determine if data represented by a quadratic is what we have by looking at those second differences. So linear data, we can look at those first differences. All we have to do is subtract the y's once, and we'll get a consistent difference, a common difference. But now we're going to find the second differences. So you always want to check the x values in your table. Make sure that they're just increasing by the same amount or decreasing by the same amount. So in this case, we're going plus 2, plus 2, plus 2, plus 2. And then you want to find the second differences for the y's. Now, it doesn't matter which way around you go. So you can go 12 minus 10, but if you do 12 minus 10, you must do 10 minus 9, and so on, right? So if we go ahead and we find those first differences, 12 minus 10 would be 2. 10 minus 9 would be 1. 9 minus 9 is 0. And 9 minus 10 is negative 1. So those are our first differences. And from that, you can tell that we would not think that this was linear. And then we can pick a different, we can go ahead and do the second differences. So now using the same way, 2 minus 1 would be 1. 1 minus 0 would be 1. And 0 minus negative 1 would also be 1. And as you can see here, those second difference is the same. So if you go ahead and you pause the video, and then you go ahead and check back for your answers. So the first option we have here is not quadratic because those second differences aren't the same. Now I'm going to do 21 minus 11 is 10. 35 minus 21 is 24. 53 minus 35 is, I believe, 18. And 75 minus 53 is, I believe, 22. Yeah, okay, so 24 minus 10 is 12. I feel like I made a mistake here. Hold on 1 second. 53 minus 35. Nope, that was correct. 75 minus 33. This way, okay. All right. Yeah, so 24 minus 10 is not 12, it is 14. That helps. And then 18 minus 24. What did I do wrong here? 35. Okay, so 35 minus 21 is also, it's 14. Wow. Apparently I can't do any addition tonight. I apologize. All right, let me kind of erase this and actually find those differences. Okay. So let's try that again. 21 minus 11 is in fact 10. However, 35 minus 21 is 14. And 53 minus 35 is 18. And 75 minus 53 is 22. All right, so 14 minus 10 is 4. Okay, 18 minus 14 is 4. And 22 minus 18 is 4. So these are, as we see, these are the same second differences. So this is quadratic. Let me just see if this actually works. It is quadratic. Perfect. Okay. So being able to determine if data is quadratic is really helpful because when you're looking at a set of data, it is important to know if you can even find an equation to correctly model it. So a lot of the times, in our word problems, we will tell you that the data is quadratic, and other times we will ask you if the data is quadratic. So we can use those second differences. So now that you have data and you've determined if it's quadratic, you can decide how to write the equation based on what kinds of points you're given. So here we have example 2, and we're going to write a quadratic function. And in this case, we know the roots. So that's really important because you don't always know the roots of the problem that you are writing. So in this case, we do know the roots. So it's important to know what the roots are. So this is when you know the roots. I was doing all that just to get my highlighter. So how do we know if we have the roots? Well, hopefully you're saying, okay, roots, that's the same thing as zeros, which is the same thing as solutions, right? And so roots are the places where the graph crosses the x-axis. So let's say we have these two roots over here, right? They're on the x-axis. So roots are always going to be x, comma, some 0, because the height of all the points on the x-axis are at 0. So when I look at my data, I'm like, oh, here you go. Here are x. Here's a root, 1, 0, and 7, 0. Those are both roots. Now, if p and q represent the roots, we can use them really easily to find the equation of the parabola. Because in order to get the roots, or the place where the parabola crosses the x-axis, right, we take factors and we set them equal to 0. So here we've got basically factored form. This is factored form. Some people call it intercept form for quadratics because it represents the x-intercepts. So basically what we're saying here is that if p and q are the roots, then x minus p must be a factor and x minus q must be a factor, because we got them by setting, for example, x minus p equal to 0, and then I would go ahead and that would give me the answer of x equals p as a solution. And if x equals p as a solution, then that represents where it crosses the x-axis over here on our graph. All right, so knowing that, here we have 3 points. 2 of them are roots, and 1 of them is an additional point, 4, 2. So we can go ahead and do this easier kind of problem by going ahead and plugging in our roots first of all. So we'd have x minus 1 here, and then we'd have x minus 7 as our other factor. And this 0.42, we're going to use the same way before. It's an x comma y point. And so we're going to go ahead and plug those in. So y is 2. We're looking to find a. X is 4. So this will now say 4 minus 1 and 4 minus 7. And we're going to go ahead and do that math. So we've got 2 equals a. 4 minus 7 is, I believe, 3, although my math is a little off tonight. And 4 minus 1 is obviously also 3. All right, and so we've got 3 times 3, which I believe is 9. So this is like 2 equals 9a. And all I'm going to do is divide by 9, which tells me the value of a. And then we're going to go back and we're going to substitute that back into our original equation. So therefore, these 3 dots stand for therefore when they finally appear on the screen. So our equation is y equals 2 over 9, which means it's a positive parabola. It's opening upwards, right? Times x minus 1 times x minus 7. So it has a slight vertical compression because it is 2/7, which is less than 1. All right, and that would be the equation of our parabola. So now on your Angry Birds problems, you should do level 1. Now I'm not going to give you any answers to the Angry Birds questions today, but you should pause the video and you should do level 1 and you should start the video again when you are done with that. And we will then go over the answers to those questions next time I see you. Okay, you should also move on to level 2. Now I want you to make sure that you pay attention to what the zeros are in level 2. And when you get the answer to that, you should pause this video, you should get the answer to that, and you should write it on the line on your note packet. And we'll go over that next class. Okay, so the ones where you get the zeros are really not that bad. They fall really nicely into the equation. But we don't always get the zeros. So when we don't get the zeros, when we don't have the roots, we need to use the quadratic in standard form to find the equation. And this is a little bit harder. So you're going to have to bear with me. What we're going to do is we're going to use that standard form. So that standard form of a quadratic is ax squared plus bx plus c. And forgive me, I am using my mouse, so this is a little bit hard. And what we're going to do is we're going to do that for each of these points. We're going to take each of these x, y values at a time, and we're going to write an equation for them. And I'm going to hopefully switch colors as long as everything cooperates, which it does not seem to be doing. So we'll give this a shot. All right, so we're going to write an equation here for this 0, 5. So a is a variable that I'm going to try and figure out what it is. X squared, right? So here's x is 0. So 0 squared, so times 0 squared, plus b times 0 plus c. And that all equals y, which happens to be in that, for that point, 5. So we have this first equation. Now the great thing about this equation, when you have this value, and hopefully you would realize that 0, 5 is a y-intercept, that tells us the value of c. So from this equation, we know that c is 5. All right, now we're going to do 2, 1. We're going to make a new equation for that one. I don't know if I can pick a different color here. Let's see if I can get a different color. Yes, I can. All right. So let's do that. All right, so now we're going to do an equation for the 2, 1. So it's a times x, and x is now 2 squared, plus b times 2, plus c. Well, guess what? C is 5. So I'm going to go ahead and write 5 equals y, which happens to be 1. So this gives me the equation for a, because 2 squared is 4. 4a, now it's not a squared because only the 2 is being squared. 2a plus 2b equals, because I'm going to minus the 5 to the other side, -4. All right, so that might look a little bit more Algebra 1-y for you, hopefully. It's like something we did in Algebra 1. All right, let me get another color now. And let's do the last value, the last kind, right here, this 3, 2. And so we're going to do the same thing, a times 3 squared plus b times 3 plus c, so don't forget c is still 5, equals 2. All right, so a times 3 squared, that would be 9a, plus 3b. And now we're going to minus the 5 to the other side. So now that's going to equal -3. All right, so hopefully you see that right here we have two equations, right? We have two equations and we've got two variables to solve for, which means that we can solve this system of equations. So what we're going to do is we're going to stack them on top of each other. And if I could switch colors easily, I would, but it is not working so well. So we've got this 9a plus 3b equals -3 equation. And underneath it, we've got 4a plus 2b. 4a plus 2b equals -4. Now, my favorite way of solving systems of equations was always elimination. I hope that is yours as well, because that is what I'm going to do right now. So in order to use elimination, we need to find a number that we could multiply the equations by. They can be different numbers, so that the coefficients match. And in my opinion right here, looking at these numbers, I think it's going to be easier to make the numbers in front of B match than the numbers in front of A. So hopefully you will agree with me. And you will see that I'm going to take this whole equation and I'm going to multiply this whole equation by 2 so that that becomes a 6. And then I'm going to multiply this whole second equation by -3 so that the other b becomes a -6. All right, so multiplying the whole equation, we now have 18a plus 6b equals, don't forget to multiply the number on the end, -6. Multiplying this whole equation by -3, we get -12a minus 6b. Okay, that wrote b6, but you understand what I mean. Equals, and then -3 times -4, hopefully, is 12, positive 12. Now, the whole reason I chose to multiply 1 by a negative was to make these guys cancel out through addition. So now I am adding these equations together. And 18a plus -12a is 6a. And -6 plus 12 is 6. And divide both sides by 6, and we end up with a equaling 1. Now, you are not done until we have figured out a, b, and c. So we have a is 1, b is unknown yet, and c is 5. So we're going to use one of these equations to find out b. Personally, I'm going to use this one, the red one. So I know that 4 times a, so 4, plus 2 times b, 2b, equals -4. So I'm going to minus the 4 to the other side, which makes 2b equal to -8. And that makes b equal to -4. So what is the equation for our quadratic? Our quadratic is a, so 1. So we're going to write y equals 1x squared minus 4x, because it's bx, b is -4x, plus 5. All right, so that is this this quadratic that models going through these 3 points. That's a lot to digest, but just to recap, we wrote every equation in standard form using the point. We filled in the numbers where we could, and then we found the y-intercepts, the 5, which made it a lot easier for us because that gave us two equations with two variables. So then we solved the system of equations by elimination, and then we found the missing value b by plugging a back into one of those equations. Okay, so you're going to pause the video and you're going to do level 3 of the Angry Birds. Just to let you know, you will not get whole numbers for these numbers necessarily. They might be decimals, and so that is okay, but make sure you are very careful. and you check your work. And then when you're ready to watch the last one, go ahead and flip to the next one and unpause. Okay, now on your sheet, I don't have an example of this, but the last possible kind that we could give you is a kind which is somewhat mean because it has no y-intercept. You'll notice here that none of these are 0, a number. And how does that change things? Well, really the only way it changes things is that it makes us solve something called a system of 3 equations with 3 unknowns. We are not going to know A or B or C, but otherwise we're going to solve it in the exact same way. So you're going to watch me now write equations for all 3 of these points and show you how to solve a system with 3 unknowns. So we're going to do A times 2 squared, which is 4. So 4A plus B times X, B times 2, which is 2B, plus C, and it will equal 3. All right, so that's the equation for the blue point right here. All right, let me change to green. And I'm going to do the equation for this point. So this is A times X. X is in this one 4. So 4 squared is 16. So we have 16A. Plus, I'm using that same standard form equation. B times X. B times 4 is 4B plus C. And it will equal 5. All right, and now for the standard equation, for the number, this one with the 6, 1. So A times 6 squared, so that's 36A, plus B times X, so 6B, plus C equals 1. All right, so what we're going to do here is we are going to take one of these equations and solve it for C. And we are going to plug that into both of the other equations. So in order to make our life a little bit easier, I think I'm going to take this first equation and solve it for C. So we are going to say if I minus 4A and I minus 2B from both sides, so I'm going to minus 4A and minus 2B to this side, then we will get C alone. So this equation will say C equals 3 minus 4A minus 2B. And we are going to take that value and we are going to plug it into the green equation where we saw C and also into the black equation where we saw C. All right, so now I'm going to attempt to rewrite these equations. The green equation should say 16A plus 4B plus, and now I'm going to insert all this for C, 3 minus 4A minus 2B. And it still equals 5. So now I'm going to combine like terms. 16A and negative 4A is 12A. 4B and negative 2B is 2B. So plus 2B. Ooh, I wrote 3. 2B. And then I'm going to minus 3 from both sides, and it will equal 2. All right, so we're going to do that exact same thing, but now we're going to plug it into the black equation. So this will say 36A plus 6B plus 3 minus 4A minus 2B equals 1. And we're going to combine our like terms here. So we have 36A and negative 4A is 32A. 6B minus 2B is 4B. And I'm going to minus the 3 from the other side, so that will equal -2. All right, well, the good thing is our b's are very simple here. In order to make them match, all I really need to do is take this equation over here. This one, I'm going to take the green equation. I'm going to multiply the whole green equation times -2, because that will now make the 4's b's cancel out. So if I multiply it by -2, it will say -24a minus 4b equals -4. 4b's cancel out. 32 minus 24, I believe, is 8a. 8a equals -2 minus 4 is -6. And if I divide both sides by a, by 8, I believe, I get a is -2/3. Now you probably are not so happy about that, but it's really not so bad. We're going to use that. So a is -2/3, and I'm going to personally plug it back into this green equation, because I can figure out 2/3 of 12 pretty easily. And I know that 12 times 2/3, actually it's -2/3. So let me write a negative sign there, plus 2b equals 2. So -2/3 of 12, you should know that is -8, right? Because I'm dividing it by 3, which is 4, and 4 times -2 is -8, plus 2b is 2. And now add the 8 to the other side. That, I believe, makes it 10. So 2b equals now 10. And that would make b equal to 5. All right, so we've got A. We got B. Now we can get C. So all we need to do is plug A and B into C. So C equals 3 minus 4 times A, which is -2/3, minus 2b, which is 5. All right, so 3. This will become plus 8/3. All right, 8/3. And then minus 10. All right, so I'm going to make these all, whoa, gotta love these numbers. 3 plus 8/3 minus 10. Now I'm going to use my calculator. 3 plus, and I'm going to use parentheses, 8 divided by 3 minus 10. My calculator is -4.33333. I'm going to hit math, enter, enter, and that gives me the answer of -13/3. All right, so some of these numbers are going to be tricky. They're not always going to come out perfectly correct. Hopefully I did not make any mistakes in there with my simple addition and multiplication and such. If you have any questions, definitely ask the people around you. And I need you to now work on level 4 of the Angry Birds sheet. That one is definitely the hardest, and so you might need to do that on a separate piece of paper. And I will be looking at this next time I see you, which is hopefully on Thursday. Be sure to make sure that you noticed that the homework is to finish the Angry Birds sheet, which you should have enough time to do now in class, and then also to check out these problems. I'm going back from the textbook, which I believe are on page 377, 378, from 12 to 24. They are not all writing the equations. Some of them are looking at that data that we looked at before. And I will see you next time in class.